you some applications of the sine and cosine rule. So I'm going to start off with an example. A ship sails 6, and it's a capital M. That capital M stands for nautical miles. This is the measure that we use for ships, aircraft, generally for real life distances that are much longer than kilometres. So a ship sails 6 nautical miles due east, so in a 90 degrees from Foley's Point to Gumpville. So if I start my diagram, due east, so remember never eat soggy Weet Bix. So starting from here at Foley's Point, remember it says from Foley's Point, due east straight across to Gumpsville. I'm going to give that a G. Hoping you can see that. I think you can. Okay, and it's 6 nautical miles. Remember it's 6 capital M. Okay, it then turns and sails 34 capital M, so 34 nautical miles on a bearing of 080 to Hellenbach. So here's where we're starting from at Gumpville. So we need to draw our north in from here. And it needs to go 80 degrees, so starting at the north and 80 degrees. Well, straight across this way is 90. So 80 is going to be pretty much out there like that. Now, actually, I'm sorry, that's 65, and this one is going to be 34 nautical miles. Now that degrees in there is 80 degrees because it's 080 is the bearing, and we're going out to Hellenbach. So that's going to be a capital H. Okay, the first question is asking us to find the distance between Foley's Point and Hellenbach. So that would be, if I draw it as a triangle, that would be this distance here. And the second question is asking me to find the bearing of Hellenbach from Foley's Point. So from Foley's Point is where the bearing is starting from, and so going across until I meet Hellenbach, it's the angle I need to find in there. Now to find that angle, it's similar to finding an angle of depression because it's outside the triangle, so I'm going to need to find the one inside the triangle. So I'm probably going to make my theta in there, knowing that my bearing is going to be 90 minus my theta, because this is not 90 degrees, it's due east, straight off at 90, north and due east make a 90 degree angle together. Okay, so let's draw a normal right angle triangle, a normal triangle just away from all of this bearing information, and we'll see if we can find the distance between Foley's Point and Hellenbach. What a name to use in an example, Hellenbach. Okay, so remember I said that was 6, it's actually 65. Sorry, I've just written that down incorrectly in my example. And this is 34. Now I know this angle here is 80, but it doesn't actually tell me what this angle over here is. However, I know this is due east. So between due east and north, which would then become west if I looked at it on this side, it doesn't matter which direction it is, it's 90 degrees. So with that being 90 degrees, me knowing that this is 80, that tells me that total, this area angle here, is going to be 170 degrees in total. Now, the first question asked me to find the distance between Foley's Point and Hellenbach. So that would be that distance that I've marked with an X here. Okay, so remember, whenever you're doing sine rule or cosine rule, you're looking to make sausages. With the sine rule, you can make 2 of them. With the cosine rule, you can only make 1, and you end up with 2 circles, hence the C for the circles, the C for the cosine rule. So the first thing I'm going to be able to do is link those to the side and the angle, so that gives me 1 sausage. I know no other angles, so I'm going to actually have to circle these 2, which means I'm going to be using the cosine rule. Now I'm finding a side. The cosine rule for a side, which remember will be on your formula sheet, is c squared equals a squared plus b squared minus AB cos angle C. So in this particular triangle, remember the C is the one sausage that you can form, and the two circles become your A and B. The order that they're in doesn't matter. This one could be B, this one could be A. It doesn't make any difference. Okay, so for this particular triangle, it will be x squared equals 65 squared plus 34 squared minus 2 times 65 times 34 cos 170 degrees. Okay, I'm going to type all of that into my calculator. Now, I've actually just realised I'm doing this at home this morning, and I've left my calculator at school, and I did have a calculator at home, but for some reason I can't seem to be able to find it. But because I'm doing the example that's out of the textbook or off the PDF, I know what the answer is going to be. So I know that I'm going to get an answer which is 9733.8502 ... Okay, square rooting my answer to get just x by itself, and I'm going to get 98.6602 ... Now the question did ask me to round it off to one decimal place. So 98 is going to 0.66, so the first decimal place is a 6. Behind that is another 6, so it's going to become 98.7. It's a capital N, remember, to stand for nautical miles, and even though you were asked, you do still need to put your rounding in brackets at the end. Now, remember, we've invented x, we now need to answer the question. So therefore, distance between Foley's Point and Hellenbach is 98.7 nautical miles. Okay, part B. We need to find the bearing of Hellenbach from Foley's Point. So as we said, here's the line that we've joined between Foley's Point. Where a bearing starts from is where you need to draw your north in. So here's Foley's Point. I'm drawing the north in here. It starts from the north and travels clockwise until I meet the line that joins up with the bearing that I'm trying to find. So here's Hellenbach's line, and I'm drawing around until I find this. Now, as we just said, the bearing sits outside the triangle. I know that between due east and north is 90 degrees, so I'm going to need to find the angle inside that triangle. So if I drew myself just a basic triangle again, it's theta here that I'm trying to find. That's 65 nautical miles, that's 34 nautical miles, and I know the angle in there is 170 degrees. Now, I could put the information over here that it's 98.7, however, I'm going to try and avoid using that if I can, because if I've made a mistake, then that's going to compound my mistake by using it again when I do my next question. So I'm going to see if I can now form two sausages or one sausage and two circles. So I can see that I'm not going to be able to find my sine rule, cosine rule, whatever it happens to be. I can make one sausage here using my theta, because obviously theta is what I'm trying to find. So theta needs to be part of that sausage, or one of those circles or sausages, the thing that I'm trying to find. And there's no other angle. I can't use the 65 because I don't know it. I can't even do angle sum of a triangle because clearly I need to find one of those. So in this particular case, I'm going to have to use my 98.7 and form another sausage that I already found over here. Now, if you have made a mistake, don't worry. If this was a HSC exam or an assessment task, you would then be expected to use the answer that you've given, and full marks would be given for working out, not for the correct answer. So I have two sausages, so that's going to be my sine rule. So remember, that's A over sine A equals B over sine B. And again, this is on your formula sheet. Okay, so starting off at the top with the thing that I'm trying to find, and again, I've written it in the wrong way. So the angle is what I'm trying to find, so it needs to be sine A over A and sine B over B. Okay, so sine A, starting off with my theta, it will be sine theta over 34 is the same link, equals sine beta, so sine B, which is sine 170 degrees, over B, which is 98.7. Now again, I don't have my calculator with me, but remember you need to bracket that up. A lot of you are finding that you're doing it on your calculator and you're not putting the brackets in the right spaces and you're not getting the right answers. So just remember to make sure you bracket up the sines and the cosines by themselves, and then you bracket up denominators and numerators again separately by themselves. Okay, so to get sine theta, I've got to multiply both sides by 34. So that tells me that sine theta will be... Oh, I don't even know what that happens to be. Guys, I'm really sorry I don't have my calculator here. But I can tell you that when you then shift sign or sign inverse your answer, you should get 3.4307 ... which, oh, that's actually not even a ... that's in degrees, I think. Oh no, that might be a ... which is going to give me 3 degrees, because the question did ask me to the nearest degree, so 3 degrees to the nearest degree. Okay, that wasn't the bearing. Remember, the bearing is sitting outside the triangle, so therefore the bearing of Hellenbach from Foley's point is going to be 90 minus that 3 degrees, 90 minus, this is 3 degrees in here, so it's going to be 87, is 87, so it'll be 087 degrees. Okay, I think now you should have enough information. You should be able to work on this by yourself anyway, but you can work on exercise 5.09, questions 5, 6, 8 and 10.